All right, so we are now on 3.7. It's called linear approximation. Linear approximation. Linear approximation. All right. So, you know what square root 4 is, right? What's square root 4? 2. No, just 2. Yeah. Do you know what square root 4.2 is? Yes, 2 and square root 2. But it's some number, right? So, without a calculator, can you approximate it?
Bigger than 2.
It's bigger than 2, right? Bigger than 2. So, what we're going to do is we're going to, we're not going to graph square root 2 because you already know how square root 2 looks like. Square root 2 looks like this, right?
Yeah.
Okay.
Wait, square root?
Sorry, square root x. Sorry, square root x. Square root x looks like that. And then square root 4. Square root 4 means, this is the square root function. So square root 4 means when x is what? 4. When x is 4, y is 2. That's what it means. So this point, 4, 2 means on the square root x graph, when x is 4, y is 2. Now what we want to do is we want to figure out where 4.2 is. 4.2 is a little bit past 4, so somewhere here, right? Now that's going to be really hard to figure out. So what we're going to do is kind of think about this a little bit. So if you actually have a graph paper and if this were really the graph, let's say I zoom in a lot.
Wow.
Does it still look like a square root x graph?
It's like glasses.
It's like Baymax.
Okay, it no longer looks like square root x. It looks like 2 dots. So it looks pretty much like a straight line, right? If you zoom in enough, it looks almost like a straight line. So what we're going to say is that when you zoom in something that is a linear, sorry, not linear, a continuous graph, so much that the graph almost looks like it's linear. Therefore, we can almost assume that it's almost like a straight line, and then we can use a straight line to predict. So what we're saying is, at this point that we know, which is 4, 2, what we're going to do is we're going to draw a straight line, a tangent line, actually. We're going to use a tangent line at 4, and then we are going to predict 4.2. It's not going to be the same number because I'm using this. Okay, we're going to use this red line. So kind of look at it. Your square root x line and your tangent line. The tangent line is going to be on top of the square root x line, right? So we're going to use this linear line to predict this curve. So then the actual number on the curve is here when the number you're predicting is here. So it's a little bit off. However, it's close enough. It's close enough if 4 and 4.2 are close. Like you can't use 4 to predict 10. It's too far. Your number is way off. Does that make sense?
Yeah.
Okay, question.
So what do we assume is close?
So we're assuming that 4 and 4.2 are close enough that when I have a straight line, I can predict this point.
Well, what's like the cutoff, like 1
Yeah.
number?
Okay, so anywhere within, I would say, a point, point or less. So 4.9 might be pretty close, or 4.5 is pretty close.
Like
5 is,
Stretching.
yeah, stretching it, but like if you say 10, right,
If it
you're
was
so far.
9, wouldn't you just guess 5?
Huh?
If it was 4.9, wouldn't you just do 5?
Right, exactly, yeah. You wouldn't use like 1 to predict 4.9. Yeah, you're right. If it's 4.9, you would use 5 to predict. Yeah, correct. Okay, so then our task now becomes, how do we create this line?
Derivative.
Yes, so it's the tangent line, right? So tangent line, remember, is, let's write it on the side. Y minus y1 equals m times x minus x1. This comes up every single unit, almost every single section. Okay, so we need that. Now, what's going to happen is you have 2 points. You have 4, which is the point you know, and you have 4.2, which is the point you don't know. And you have a slope. Since you're creating a linear line of the original point that you know, you're going to use that slope. Okay, this is pretty complicated to show you, so I'm going to show you a different way. So what you're going to remember is your slope is basically y2 minus y1 over x2 minus x1, right? Okay. Another way to do this is your A-rock formula, right? This is pretty much A-rock. So let's say that it's f of x minus f of a over x minus a. Yes? You guys are still good, right?
Yeah.
That's equal to the slope. The slope is f prime of a. Now the question is, what is a and what is x? A is always going to be the point that you know, and x is always the point you don't know. So you're using the point you know to predict the point you don't know. Okay? Yes, you got to understand the concept because not every question is going to be asked the same way. Once you understand why you do what you do, then you can apply. Yes?
Why do we use A for the point that we do know?
A is the point you know. So, huh?
He's asking why A, why not like B or C?
Oh, why the letter A?
Yeah.
Oh, you can use any letter you want. I just chose A.
Or like instead of X.
X is more usually as like the point you don't, like the variable. So we want to use X to represent the one that we want to find.
But A is a variable too.
Yes, but usually in this, context, f of x is always the unknown. F of a being always the number you know.
Does it really matter?
Okay. So you're going to remember this, and then we're going to solve some problems. All right. So when something is small enough to the original value, we can approximate it by the tangent line. So whatever number we want, it's going to be close enough to that tangent line that we create. So this is called the linear approximation. Linear approximation. This is a kind of like keyword. When it says linear approximation, you're going to do this. Okay, let's look at one example. Okay, let f of x equal square root x plus 3. Find an equation of the tangent line to the graph of f at the point where x equals 1 and use this linearization to approximate f of 1.05. Is the approximation an overestimate or underestimate of the actual value? That's a lot of information. Okay, so you have a function, f of x equals square root x plus 3. So in your mind, imagine how it looks like. Square root x, move to the left 3. You're going to create an equation of a tangent line to this graph at the point where x equals 1. So, okay, first draw this graph. At 1, you're going to create a line, and you're going to use this line to approximate 1.05. So 1.05. And then you're going to say whether your estimate is going to be overestimate or underestimate. You can pretty much tell right now, right? Is it going to be an overestimate or underestimate? Overestimate. Why is that? It's above. It's above. Okay, so now we know it's going to be overestimate, and I'm going to show you how to justify your answer. Okay, so we need to first find a line. To find a line, we use that formula I just gave you. M is equal to f of x minus f of a over x minus a. That's equal to m. M means slope. Slope means derivative. Derivative at a. Okay, we now have to figure out what is x and what is a. Remember, a is the known, x is the unknown. So this is a, this is x.
Wait a minute.
Yes?
X equals 1. A.
Yes.
Oh, tricky.
Yes. So the known number, the number you can calculate with, is going to be your a. Okay? You can't calculate with 1.05. It's not possible. So 1.05 is going to be your x. All right, let's go ahead and put everything we know in here. So the first thing is they just want us to create a equation of tangent line. So let's not actually put in the point for the unknown. So just f of x minus f of 1, that's the known point, x minus 1 equals f prime at 1. The next thing we're going to do is put in all the numbers we know. So f of x, we don't care at this time. They just want a line, so we don't really need that line. Or we don't need to know f of x. So just leave f of x as is. What is f of 1?
2.
Good.
That's for
Square root of 3 plus 1?
yes.
Okay, f prime of 1. This one we need to do some work on the side.
Wait,
where'd you get x minus 2?
X minus
I'm sorry, x minus 1. Okay, f prime of 1, so we got to find f prime of x. So derivative of square root x plus 3. 1 over 2 square root x plus 3. And then plug in 1, which is 1/4. Okay, now we're going to just solve for f of x to create that line. F of x minus 2 is equal to 1/4 times x minus 1. And then just add 2. Oh, I'm sorry. Okay, so this is the line. This is the linear line that goes through point 1 on this graph. We are going to use this line to predict what's going on at 1.5. So 1.5 is the x. So this is going to be f of 1.05. 1.05 equals 1/4 times 1.05 minus 1 plus 2. And you just need to calculate that. Okay, you're trying to figure out what f of 1.05 is, so 1.05 goes into x. Okay, you can't use your calculator?
Oh, we can?
Yeah.
If we're using our calculator, why not?
Yeah, why not just...
Because they want you to approximate.
But if we have a calculator...
Or not use your calculator. If that is your preference, since you're kind of complaining about the calculator. You are, definitely. Okay, if you didn't use a calculator, you would get 2 and 1 over 80. If you use a calculator, it would be 2.0125.
Yeah.
Okay, so we said that the answer is an overestimate because it's going above the curve. So when the tangent line is above the curve, that means what concavity does my graph have? Down. It's concaving down. That's why my tangent line is above. Yes?
How'd you get 80?
Okay. All right. Algebra questions, save for later. Okay. So then you need to prove that it is concaving down. How do you prove that at that point it is concaving down? Second derivative. All right. So we need to figure out what the second derivative at 1 is. So we just want to know if it's positive or negative. That way we can prove to them that yes, it is concaving down. And because it's concaving down, my line has to be above, which means it's overestimating. Okay, so second derivative. I think it's negative 1/4.
Why are we using the second term?
Ask the people arranging.
She doesn't know either.
She doesn't know either. Okay, we're
Finding concavity.
Oh, okay.
This is to the 3/2, right? I think. Okay, so we're gonna put in 1. Should be. Okay, I guess it really doesn't matter what the number is. It is gonna be negative. So then in your justification of is it going to be an overestimate or underestimate, you're going to say overestimate. Overestimate because what?
Because it's concave down.
Because, it.
Second derivative outwards.
Yeah, because second derivative is concave.
The graph, what graph?
Second derivative graph is concave. No, the original graph is concave down.
Okay, let's give the original graph a name.
F.
F.
X.
F of x is concave down. Is it always concave down?
Because F.
Out. Yeah.
Second derivative F.
We don't know.
Yes, it
outwards.
is.
So then,
Entire function.
f of 1 is concave down. Overestimate because f of 1 is concave down. So you're saying at that point it's concave down, so then your line must be above. That's kind of the inferred information. Okay, let me ask you, can you write overestimate because f double prime is concave down?
No.
Because it's not.
Because it's not.
Because it's not.
Negative.
The second derivative is negative. The shape is not concave down. The original graph, which is f of x, that shape is concaving down. So you have to be specific. This will be incorrect. Yes? Yeah, if you want to say f double prime, you would say because f double prime at 1 is negative. Okay? So please be careful with that explanation. All right, let's have you try one.
Is that it?
Yeah, that's it. That answers the whole question. Find the equation, approximate, and then whether it's an overestimate, explain.
Is that all we're learning today?
Yes. Now let's practice. All right. Find the linearization of this. All right. When they say find the linearization, they meant find the equation. So when they say find the linearization, they just mean find that tangent equation. Okay. So please know what that means. Okay, find a linearization, find a tangent equation of this function at this number and use it to approximate f of negative 1.2. You have to also say, is approximation overestimate or underestimate of the actual value? All right, how do we start? Let's make sure we all know how to start.
Label your stuff.
Label your stuff,
Set it up.
set it up. How? M equals
N equals
f of x
minus xa over x minus a.
Equals to
F prime.
f derivative at where?
A.
A. What number is a?
1.
Negative 1. So that means x is negative 1.2. All right, the first task is just to find a line. So you're not actually going to put in negative 1.2. You're just going to solve it with f of x and x in there. You're trying to find a line. Okay? Go ahead and do that. If you are stuck, please let me know. This one, the numbers turn out really nice, so it's not too hard. Whoops. F of negative 1 over x plus 1 equals f prime of negative 1. If you put a negative 1 into the function, you get 2. Okay, take the derivative. That is 2e to the negative x plus 1 times chain rule, negative 1. So negative 2e to the negative x plus 1. Okay, now put a negative 1. You're going to get negative 2. Okay, solve for f of x. F of x minus 2 equals negative 2 times x plus 1. So then f of x equals negative 2 times x plus 1 plus 2. So this is your local linearity equation or linearization. Yes.
How do you get rid of the E?
How do you get rid of the E?
Yeah,
It-
the E just disappeared.
Yes, because
Zero.
e to the 0 is 1. Okay, all right. The next thing is we need to estimate this number. All right, so no calculator. Estimate f of negative 1.2. So f of negative 1.2 is equal to 2.4. And then once we take the second derivative, it actually turns out to be the same as the original function. So then f double prime of negative 1 is positive. So then this is going to be underestimate because f of negative 1 is concave up. Okay, let's try one with a multiple choice. Choosing the right answer sometimes is hard.
Yes.
What questions do you guys have?
None.
Second
This is
derivative.
good. I'm excited for this.
Huh?
Yes.
F double prime.
How's it
No,
positive?
it's like underestimate because F negative 1.
I don't know why.
It's concave up.
Should it be
No. We're using f of negative 1 to create a line. So we don't know what f of 1.2 is doing, negative 1.2 is doing. We're going to use that line. And that line is overestimating the graph because the graph is concave up. So therefore, the tangent line has to be above.
Can you do the double F double prime negative 1? Like,
You mean plug it in?
yeah.
If you plug in negative 1, it's going to be e to the 0. E to the 0 is 1. Sorry, 1 times 2 is 2, so it's positive.
Wait, you
What
used
happened to the
it.
negative?
Wait.
Okay, you take the first derivative, right? If you take the derivative again, it's going to be the same function times negative 1. That negative 1 and this negative 2 will make it positive. So we go back to the first function. Yes.
So we plug in a into the second derivative.
Yes.
X.
Because you're saying, is this line above or below? That line came from the negative 1, that point.
Okay. Oops. Didn't really affect much.
Okay, next. All right, we're not going to do this one. Okay, so I'm going to write down the question for you. So my writing speed and your writing speed should be about the same.
I
Okay,
hope so.
I hope so.
I'm gonna write about that.
What is the local linearization of f of x equals x e to the x at x equals 0. Oh, sorry, not x. A equals 0. What is the local linearization of f of x equals x e to the x at a equals 0? What are they talking about?
Tangent line.
Tangent line. They want the equation. Okay, you have 4 choices. L of x. So they often use L because they're talking about the linear line.
Oh, that's smart.
Okay, B is L of x equals EX. C is L of x equals EX plus 1. D is L of x equals x plus E. Okay, which one? A. Yes. Okay.
Can you explain?
Yeah.
Okay. All right. M is equal to f of x minus f of a over x minus a equals f prime at a. All right. F of x minus f of 0 is 0 over x minus 0. That's just x equals product rule.
Oh, I didn't even do that.
X e to the x plus e to the x at 0, which is 0 plus 1. So 1. 1. Then just f of x equals x. All right, the last one. This one, please read it with your partner and try to decipher what the question wants you to do, because the problem is understanding the question. Right? It's not the solving part. It's make it bigger. Again, the trick is in reading the question, right? Try to understand what it's trying to tell you. Okay, f is a differentiable function. You have this point, and the derivative at that point is 5. If the tangent line at 3, tangent line at 3, is used to approximate a 0. We want a tangent line at 3, and that line is going to figure out what the 0 is, meaning what x value makes f 0. The approximation is, all right, tangent line approximation should tell you you need to write this, right? Tangent line approximation. That's good. So now you have to figure out what is x and y and all that stuff, right? Or a and x. So this definitely has to be a. There doesn't seem to be an x. So let's just go with it. So f of x minus f of 3 over x minus 3 is equal to f prime of 3, which they tell us is 5. So let's go ahead and put everything in. F of x minus 2 over x minus 3 equals 5. They want a 0 of f. 0 of f means when y is 0, what number is x? That's what it means. So 0 minus 2 over x minus 3 equals 5. So negative 2 equals 5 times x minus 3. So negative 2 over 5 equals x minus 3. X is equal to 3 minus 2 over 5, which is 13 over 5. So 2.6.